Hello again. In this lesson, what we're going to be looking at primarily is how Maya translates what we see on the screen into math, essentially. What we're going to be doing is we're going to be looking at how tangents change the way objects move inside of this space. So as you can see, I have three spheres here, and we notice that on frame 1 and frame 60, you can see that all three of the spheres move from one side of the graph to another. Now, the difference in how these objects are going to move from one place to another relies on how the computer has been told to translate the key spaces from this key to this key, how point A to B is supposed to change. So if I just play this through, we see that they all start and end at the exact same time. But the big difference that changes how these objects move through the space is because the spacing has been changed based on their tangents. And we see that by going into the graph editor. Now, on the side over here, we have our little preset window options. I have chosen the one layout for perspective on top and the graph editor on bottom. You don't necessarily have to do that. If I have, let's just go back to this window, I can always come up to my windows, over to my animation editors, and you can see I can have a floating graph editor in front of me. Either way works fine. I'm just going to stick with using that little window for now, for no particular reason other than that's what I feel like. Now, when I select these three objects, we can see that each one of them has a start frame and an end frame. But how they get from point A to point B varies differently on this grid. Now, because these objects are really only changing in this one direction, we can get rid of a lot of this extra unnecessary animation keyframes simply by going to Edit, Delete by Type, and choosing to delete the static channels. In other words, channels that never changed even if they have animation. So these have keyframes, but you see that they are flat. There's no change from one to the other. So when I change or delete the static channels, notice now that all three of my spheres now only have the translate x, the direction that they really are changing the values to. This will let us look at all three of them a little bit faster. Now, the first, excuse me, the first sphere that I have has a very strange keyframe. It doesn't seem to be doing anything until it suddenly snaps forward. Now, this particular kind of keyframe is known as a stepped key. And the reason that it's a stepped key is that once you have enough of them, it starts to look like a set of stairs. It looks like you can take a step from one to another. Okay, easy way to remember it. But basically what it really means is that there is absolutely no change whatsoever until the value is different. Then it will be an instant change. Now this is very useful, especially for setting up and sort of blocking out your animation. If you know that some action is going to take exactly 60 frames to get from one point to another, you can set the character or the object or whatever it is you're animating so that its start frame and its end frame are the two things that are most important, so that's where you start. Now, the next sphere that I have is using what is often referred to as easing in and easing out type of actions. And the tangents that I chose to make for that, if I just right click when I have it selected inside of tangents, were flat. Flat allows me to slowly ease into an action and then slowly reduce speed to the key. And you can see that as I start to drag it forward. Now I'm going to zoom in just a little bit so you can see it. Notice that it seems to take a little longer, but then picks up speed and then starts to slow down to find the endpoint. Okay? Now in the last sphere that I have what are known as linear keyframes. What that means is that it is evenly distributed across the entire time. No one or two frames is faster or slower in the amount of change as the last. So you can see that this sphere moves very evenly, sort of robotic, from one point to another. Okay? So let's start to see how tangents really affect and how we can really translate this into our actions. I'm going to start with this sphere in the middle, the one that had the flat tangents. If we look at just the first portion of this, we can see very easily that it starts out moving very, very slowly because it's almost horizontal. There's very little change at the beginning. Then, around here, it really starts to pick up speed and then starts to level out to then go back to almost horizontal again. Well, if I changed the angle of that first curve, so let me just pull out so you can see the entire thing. I can use these little handles on either side, and I'm selecting just the one and using my middle mouse button so that I can rotate it. Let's try to imagine, just by looking at this curve, how the animation will change now. So, beforehand, any of this is simply not moving at all. Then, in the very first frame, it seems to have very, very quick, almost instant change. It's jumping relatively quickly. Now, at a certain point, it reaches a moment where this speed starts to level off and starts to go very, very slow, almost as if it's not moving at all. And depending on how horizontal this end is, it might actually be no change at all. So let's just hit play and see how that third sphere, or that middle sphere, changes in what it used to be doing. Do you notice how it looks like it just shoots off as quickly as it possibly can and then sort of comes to a rolling stop or a very, very slow ease into that position? Now we can do the same thing by going in the opposite direction. So again, I'll just put this back the way it was. And now I'll grab this one and I'm going to rotate it so that we're basically creating the opposite action. So now let's see if we can translate what we see into what we can assume we're going to get. So at the beginning of this animation, we're going to get little or no change at all because this is very, very flat. And then it's going to very, very quickly ramp up speed until it reaches the end. So let's see how that looks. Okay, so we can see that there was very little change at the beginning here, and then it really starts to pick up speed and then quickly finishes. Now, the interesting thing to look at while we're watching all of these different actions change is that while we are changing how the object gets from point A to point B, we haven't changed when it reaches the next position. And that's really important. That is the big difference between timing and spacing. Timing says this action takes 60 frames to get from one to another. But the spacing informs us as to how it got there in the first place. So they all have a start position. They all have the exact same end time. The only thing that keeps changing is how it got from point A to point B, the spacing. So let's look and see, because something happens at the very beginning of this when we start playing. Notice how it looks like it wobbles a little bit? Well, that's because if we looked at this key very, very closely, we would see that it actually does pop up ever so slightly and then actually go back down. And what I'm doing right now is holding Alt and Shift and using my right mouse button. Now this isn't changing the animation at all. All this is doing is changing sort of my perspective of it. Okay? This can help us or it can hurt us. So just be very careful when you use this option. But because I sort of over-exaggerated the values here, notice that they used to be, 1, 2, 3, 4, or possibly 2, 4, 6, and on. We're looking now at fractions of a value. This way, though, I can really see that at the beginning of this animation, the sphere does actually move forward ever so slightly and then sort of draws back before it starts moving forward. And the important thing to realize here is that all of these values on the graph translate into different ways of motion. So keep in mind, your very first assignment is going to be, bouncing spheres that are falling off of a table, things like that. Up and down aren't necessarily on the graph up and down. Now, for our sake, moving the object up and down would create an animation curve that goes up and down. But notice that even our X direction seems to look like it would be going up and down. But that's not really what's happening. These you have to think about in terms of values changing over time or over frames. And the way that animation is dramatically changed within a certain number of frames is how we change the spacing. Now, I created a very odd curve. This is no longer going to move just from here to here. But notice, I still have not created any new keyframes. So with just that, I'm going to hit play. Okay. Notice that what I've just created is an animation that allows the sphere to go all the way past its own stop point, turn around and go back to almost where it began, and then still end in the same place. Now, if I select just that one curve again, and I angle it back the way we had it, then we'll go right back to the original motion. So clearly, the graph editor is a very powerful tool, and it takes a little bit of time to understand how this translates into what we see here.